Hi everyone, I'm Beto, a partner engineer on the Llama team here at Meta. One of the main features of Llama models is their customizability. With the appropriate dataset, our models can be customized for diverse uses, from semiconductor manufacturing to medical research. In this video, we will cover another use for image-to-text features of the Llama models: extracting data from images in JSON format. By fine-tuning Llama 11v Vision Instruct, in a mere 500 examples, we see performance improve to approximately 98% on our custom benchmark for image-to-JSON extraction. We also verified with standard benchmarks that the model doesn't lose any of its previous knowledge, effectively incorporating a new capability to its toolbelt. Let's jump right in. We will start by installing a new Conda environment and all the required dependencies. We are using TorchTune for this project and downloading the models from Hugging Face, so make sure you have access to Llama and a valid session in your machine. This setup was tested on a single H100 with 80 GB of VRAM. We are using a public dataset of synthetic W2 forms with 2000 entries, split between 1800 items for training and 100 examples for both test and validation. In our testing, we verified that a subset of the training data was enough to improve performance to the desired level. We merged the test and train splits to create a new 30-70 split between train and test respectively. This also creates greater diversity in the test set, increasing the confidence the model will behave as expected when encountering new data in production. To generate the new split, we ran the prepared dataset script with the desired 0.3 ratio. This creates a new folder in the current directory with our new split. The script also adds a prompt column with a simple prompt to match the layout expected during training. Let's run the base model against our custom evaluation benchmark to know where it stands before we start customizing it. For this, we start up a local VLM server with the base model. Even with structured JSON decoding on the API, we can see the model can only accurately extract about 56% of the data and has an error rate on the JSON output of 12%. During fine-tuning, we tested both full parameter and LoRa configurations. But there is a catch. The default full parameter configuration from TorchTune for the 3.2 Vision models does not train the decoder by default. This means that only the Vision encoder and fusion layers are being trained in our case. This allows the model to better understand image inputs while leaving text output performance untouched in other tasks. Even for our structured output use case, there was no need to also train the decoder to get good performance. After fine-tuning for 5 epochs in under an hour, we reload the model VLM. As a result of the fine-tuning, the accuracy on the test set increases to around 98%, and the error rate drops to 0. This shows how a small dataset can produce great results for a specific use case. Now you can extract any new W2 form into JSONs with confidence. We also provide instructions on how to run common industry benchmarks to test if the model still performs as expected. We tested against DocVQA, IfEval, GSM-8K, ChartQA, and saw no significant loss in the performance across these benchmarks. This is due to the small dataset and the configuration that keeps the decoder layers fixed even in the full parameter setup. Thanks for watching! Head to the link in the description box below and start customizing Llama for your use case. We are actively developing new features and capabilities, so join us on GitHub to stay up to date.